Imagine a lone hiker standing atop a majestic mountain peak. The air is crisp, the view breathtaking, but isolation sets in as they realize how far they are from civilization. They are surrounded by nature's grandeur, yet utterly alone. High in the remote Andes Mountains, an injured hiker lies helpless, their situation growing dire with each passing moment. They are far from any established trails with no immediate access to help. The vast, unforgiving landscape stretches out before them, a stark reminder of their vulnerability. In the past, this could have meant disaster, a tragic tale of isolation and despair. Without a way to call for help, their fate would be left to chance, a race against time and the elements. But today she pulls out her ordinary smartphone, a device that has become an extension of ourselves, a lifeline to the world beyond. With trembling fingers she types and sends a message for help, a beacon of hope cast into the digital void. It's a simple act, yet it holds the power to change everything. The signal, faint but determined, travels straight up, defying the limitations of terrestrial networks. It's a testament to human ingenuity, a bridge built between Earth and the stars. It's reaching a tiny satellite, a technological marvel, silently orbiting overhead, a sentinel watching over our planet. This small but mighty device is a key player in a revolution of connectivity. That satellite, a tireless messenger, relays her message across vast distances, bouncing it through the cosmos with incredible speed and precision. The message arrives at an emergency center thousands of miles away, a place of calm amidst chaos where trained professionals stand ready to respond. Help is on the way, dispatched with urgency and expertise, a symbol of hope cutting through the sky. This isn't science fiction, it's not a scene from a futuristic movie. It's the dawn of a new era in human connection, a transformation that is reshaping our world and redefining what's possible. Direct-to-cell satellite communication, a groundbreaking technology, is erasing the world's final dead zones, those frustrating pockets where connectivity simply vanishes. A research vessel in the Pacific, far from any coastal infrastructure, can now send critical data in real time, accelerating scientific discovery and understanding of our oceans. A family in a remote village, isolated by geography and circumstance, can let loved ones know they're safe after a storm, offering reassurance and peace of mind in the face of adversity. This technology is more than just an upgrade, it's a universal safety net, a digital safety net, binding every corner of our globe, creating a web of connection that transcends borders and boundaries. For decades we've relied on fragile networks, vulnerable to the whims of nature and the limitations of geography. We've built our connected world on a foundation of cables and towers, a complex infrastructure that is susceptible to disruption. We've grown accustomed to accepting dead zones as a fact of life, an unavoidable inconvenience in our increasingly connected world. But what if your connection wasn't limited by geography, by the reach of the nearest cell tower, or the presence of buried cables? What if the network was everywhere, a constant presence like the sky above, a boundless expanse of connectivity that surrounds us all? This leap isn't just about convenience. It's not just about being able to stream videos or check social media from anywhere. It's about resilience and equity, about ensuring that everyone has access to the tools they need to stay safe and connected. When disaster strikes, when the earth shakes or the storms rage, ground networks fail first, leaving communities isolated and vulnerable. Direct-to-cell satellites offer a lifeline, a reliable connection that can be the difference between life and death. It's a connection that remains intact, unwavering in the face of chaos, a beacon of hope in the darkest of times. Our personal devices become powerful survival tools, transforming from everyday gadgets into essential instruments for safety and security. They become capable of reaching out from anywhere on Earth, connecting us to help, to information, and to each other. The promise: a world where no one is left in silence, where every voice can be heard, no matter where they are, no matter how remote or isolated their location may be. The future of connection is global, a network that spans the entire planet, resilient, able to withstand the challenges of our ever-changing world, and always within reach, ready to connect us when we need it most. Welcome to the age where your phone can call the cosmos, where a simple device in your pocket can connect you to the vastness of space, and get an answer, a response that could save a life, spark a discovery, or simply bring us closer together. So, what exactly is direct-to-cell, often abbreviated as D2C communication? It's a groundbreaking technology that's poised to revolutionize how we connect with the world around us. Imagine a world where your phone works everywhere, regardless of cell tower availability. That's the promise of direct-to-cell. It essentially turns satellites into cell towers in the sky, creating a network that blankets the Earth. These aren't your grandfather's satellites. They're sophisticated communication hubs designed to interact directly with your everyday devices. The beauty of it is that it lets your regular smartphone connect directly. No special hardware or cumbersome adapters needed. You won't have to buy a new phone or any extra equipment. Unlike old satellite phones, which were often bulky, expensive, and required specialized subscriptions, D2C works seamlessly with the phone you already have and use every day. It integrates into your existing mobile experience. Several companies are at the forefront of this technological revolution, including AST SpaceMobile, Link Global, and SpaceX's Starlink, each contributing to the development and deployment of these innovative satellite networks. And they are actively working to make this a reality right now, pushing the boundaries of what's possible in satellite communication. The real breakthrough, the core innovation that makes all of this possible, is that these satellites speak the same language as your phone, using the same communication protocols. They're designed to communicate using standard 4G LTE or the faster, more efficient 5G protocols. When your phone pings, searching for a cell tower signal, the satellite answers, responding to your phone's request for connection. To your phone, it appears as just another cell tower, a familiar point of connection. The only difference is that this tower is moving at an incredible 17,000 miles per hour as it orbits the Earth. This seamless handshake between your phone and the satellite effectively eliminates the need for expensive and often impractical ground infrastructure in hard-to-reach places. Building traditional cell towers is an incredibly expensive undertaking, requiring significant investment and logistical planning. And in many remote areas, construction is simply impossible due to geographical constraints or environmental concerns. Direct-to-cell satellites bypass this infrastructure challenge entirely, providing coverage where it's needed most. Now, the same phone you use effortlessly in the city, with its reliable network coverage, could potentially be used to call for help from a deserted island, connecting you when you need it most. The cellular network is no longer confined to just land-based infrastructure. Instead, it's evolving into a celestial grid, a network of satellites enveloping the entire planet. True global connectivity is rapidly becoming a tangible reality within our reach. It's not just a far-off dream anymore, it's an achievable goal. The sky is no longer the limit to our connectivity, it's becoming the very foundation of the network itself. Let's delve into the intricate mechanics that make this groundbreaking technology possible. We're going to explore the core components and processes that enable direct-to-cell communication, connecting your phone directly to satellites orbiting the Earth. Behind this cosmic connection, it's a symphony of engineering and innovation working in harmony to bridge the gap between terrestrial networks and the vast expanse of space. D2C systems use constellations of small satellites. These aren't your typical geostationary satellites. Instead, they form a dynamic network, working together to provide continuous coverage across the globe. In low Earth orbit, just a few hundred miles up, this lower altitude is a key factor in the system's performance, offering several advantages over traditional satellite communication. Being closer means your phone's signal can reach them reliably. The shorter distance reduces signal loss and latency, ensuring a stronger and more responsive connection. This proximity is crucial for seamless communication. These satellites are flying cell towers, essentially acting as extensions of terrestrial networks in space. They're designed to handle the same types of signals and protocols as your everyday cell tower, equipped with massive phased array antennas. These advanced antennas are the key to focusing the satellite's signal and directing it precisely where it's needed on the ground. That steer beams to target users on the ground. This beam steering capability allows the satellite to dynamically adjust its coverage area, ensuring that users receive a strong and consistent signal even as they move. As satellites speed overhead, traveling at thousands of miles per hour, their position relative to users on the ground is constantly changing. They dynamically adjust to maintain your connection. Sophisticated tracking and control systems ensure that the satellite's beam remains locked onto your device, providing uninterrupted service. They use the same radio frequencies as terrestrial networks, seamlessly integrating with existing cellular infrastructure. So your phone connects without modification. No special hardware or software is required, it just works. On the ground, gateway stations play a crucial role in bridging the gap between the satellite network and the rest of the world. link the satellite network to the global internet and phone systems. These stations act as hubs, routing traffic and ensuring seamless connectivity. Challenges remain. Satellites move fast, presenting unique engineering hurdles that must be overcome to ensure reliable communication. So the system must correct for Doppler shifts and signal delays. These effects, caused by the satellite's motion, can distort the signal and degrade performance if not properly compensated for. Latency is low enough for calls and texts, making it a viable option for basic communication needs in areas with limited or no terrestrial coverage, but not ideal for high-speed gaming. The round-trip time for data to travel to space and back is still a limiting factor for real-time applications that demand ultra-low latency. Your phone's battery works harder to reach space, as it needs to transmit a stronger signal to reach the satellite. But engineers are minimizing the impact. They're constantly working on optimizing the system to reduce power consumption and extend battery life. The result? A seamless link, a connection that feels as natural and reliable as your everyday cellular service, from your hand to the stars and back. It's a testament to human ingenuity and our relentless pursuit of connectivity. The technology is complex, involving advanced engineering and sophisticated algorithms, but the experience is simple. Connect from anywhere. Whether you're hiking in a remote mountain range or sailing on the open ocean, you can stay connected to the world. The sky is now part of your network. It's an exciting new frontier in connectivity, promising to bring the benefits of mobile communication to everyone, everywhere. Low Earth orbit is now a bustling superhighway key to direct-to-cell communication. Traditional satellites are too far for real-time phone connections, but LEO satellites just hundreds of miles up make it possible. Hundreds or thousands of satellites work together, handing off your signal like runners in a relay race. Massive antennas unfold in orbit to catch the faint signals from ordinary phones. Building and managing these constellations is a huge feat, made possible by cheaper rocket launches. Satellites must dodge debris and each other in this crowded region. This intricate dance is the invisible backbone of our connected world. The LEO superhighway is transforming how we communicate, everywhere, all the time. The future of connectivity is orbiting above us. The real power of direct-to-cell technology is its impact on people's lives. Emergency services can now coordinate anywhere, even when ground networks are down. Billions in rural or remote areas gain instant access to information, education, and healthcare. A farmer can check weather forecasts, a child can access online learning, adventurers and explorers have a safety net in their pocket, making the world safer to explore. Families stay connected, businesses operate efficiently, and cultures share stories globally. D2C bridges the digital divide, empowering people no matter where they live. It's about more than technology. It's about opportunity, safety, and human connection. Every voice can be heard, every person linked to the global conversation. The last gaps in our network are closing, no one is left in silence. As we connect the world from space, new threats emerge. Satellites are tempting targets for hackers and hostile nations. A compromised satellite could disrupt communications or be used for espionage. Data sent between phones and satellites can be intercepted if encryption fails. Ground stations are also vulnerable. An attack there could cripple an entire network. As we rely more on space infrastructure, its security becomes a matter of global safety. Our new lifeline must be protected from those who would turn it into a weapon. Direct-to-cell technology raises urgent privacy questions. With global coverage, surveillance potential grows. By companies and governments alike. Location tracking from space can help find lost hikers, but also monitor dissidents. Data and metadata are valuable for both commercial and political purposes. Who sets the rules for privacy when your data crosses borders and orbits the planet? As the network grows, we must demand strong protections for our fundamental rights. The race to fill the sky with satellites is outpacing our laws. Old treaties weren't designed for today's commercial space rush. Without clear rules, orbital congestion and debris threaten all satellites. National security concerns blur the line between commercial and military assets. An attack on a satellite could spark international conflict. Accountability and legal recourse are murky in this new frontier. We need global agreements before the sky becomes a lawless battleground. We stand at a crossroads. Global connection is within reach, but so are new risks. The same satellites that unite us can also be used to surveil or disrupt. Commercial competition is outpacing safeguards and regulations. The question isn't whether to embrace this technology, but how. Will we build security, privacy, and ethics into the system or race ahead blindly? The sky is a shared inheritance, we must protect it wisely. Let's connect every human but guard against the perils of progress. Our leap to the stars should uplift all of humanity, not compromise our freedom. From the screen in your hand to satellites in the sky, the next chapter of connectivity is already unfolding. But in the race to reach everyone, everywhere, who's watching the gates? If you found this fascinating, don't forget to like, share, and subscribe to Cosmic Chronicler for more deep dives into the future of space, tech, and the universe that connects us all. Until next time, stay curious, stay safe, and keep looking up.